Elias and Sarah are miles from the trailhead, and their high-tech gear has completely failed in the freezing rain. Without the protective shell of modern technology, the human body loses heat incredibly fast. In these conditions, hypothermia will drop their core temperature to a lethal level within a matter of hours. To survive the night, they have to stop acting like consumers waiting for a rescue and start engineering a solution using the physics of the forest around them. They begin constructing a debris hut, a custom-built thermodynamic barrier designed to halt the transfer of heat away from their bodies. They start by wedging a sturdy ridgepole between a tree and the ground, then pile on a massive 3 to 4 foot thick layer of dead leaves, moss, and pine needles. This diagram shows how the thick debris layer works. It creates thousands of microscopic pockets of still air with incredibly low thermal conductivity. Because this trapped air can't circulate, radiant body heat hits the walls and bounces back, creating a stabilized microclimate. By engineering this thermal barrier, they have successfully stabilized their core temperature and neutralized the immediate threat of the cold. With the shelter complete, the next objective is generating fire to process food and water. They build a bow drill. This requires specific geometry, a blunt-tipped wooden spindle, and a baseboard carved with a highly precise V-shaped notch cut from the edge to the center. This schematic illustrates the mechanics at play. The rapid back-and-forth sawing motion generates intense localized friction, grinding off fine wood dust that collects right inside that V-notch until it hits a critical threshold of 800 degrees Fahrenheit. Human kinetic effort is converted directly into thermal energy, triggering an autonomous, self-sustaining chemical reaction. They have engineered fire. Now they need hydration. The surface water nearby is full of invisible pathogens and runoff, so they construct an earth filter to systematically strip those hazards away. The top physical filtration layer is packed with fine sand or diatomaceous earth. As water trickles through, the tightly packed grains physically block large microparasites from tassing. The water then hits a layer of crushed charcoal pulled directly from their campfire. The highly porous carbon chemically absorbs agricultural runoff and toxic compounds. Finally, they drop twisted scraps of copper and zinc into their collection container. The metals create a weak galvanic current that releases ions, systematically rupturing the cell walls of remaining bacteria. That specific galvanic sterilization process is so chemically robust that NASA engineers utilized it to keep Apollo astronauts safe in orbit. By stacking these natural mechanisms, Elias and Sarah have effectively built a multi-stage chemical purification plant out of dirt, ash, and scrap metal. Securing calories in the wild normally burns more energy than it yields. They need a system that hunts for them while they rest. They set up a Paiute deadfall. This trap uses a complex arrangement of wooden levers, a thin piece of cord, and a small toggle to suspend a massive crushing weight in midair. This diagram shows the hair trigger physics. By minimizing friction between the carved sticks, the entire heavy load transfers into unstable equilibrium. The tension is balanced perfectly. The lightest touch on the bait stick instantly collapses the structure, bringing the rock down. The trap stores gravitational potential energy and releases it on command, acting as a mechanical extension of their own physical reach. With their core needs met, Elias and Sarah begin engineering their escape by gathering logs to build a raft. A raft requires bindings with immense tensile strength to survive the river current. They harvest stinging nettle plants, crushing the stems to extract the tough inner bast fibers. Here we see the physics of the reverse wrap. By twisting two separate fiber strands in one direction and then crossing them over each other in the opposite direction, the opposing rotational forces physically lock the fibers tightly together. That simple application of mechanical torque turns fragile plant material into durable structural infrastructure. Elias and Sarah push their raft out into the water. They are no longer victims waiting for the elements to dictate their fate. True survival has nothing to do with the branded consumer gear you carry into the woods. It requires a deep mechanical understanding of the physical world. Human sovereignty is achieved when we stop fighting nature and instead forge a deliberate partnership with its fundamental, unbreakable laws.